All right, so 3 there says, this is actually definition 3. We're going to get to definition 3 today. But the first thing you have right there, it talks about the unit circle. So the very first picture right up here says, or it has a picture of a unit circle here, and it says my formula for that is x squared plus y squared equals 1. So what we were doing way back in definition 1, this was chapter 1, we did it in terms of x, y's, and r's. Remember that? So we said that sine was y over r, and cosine was x over r, and tangent was y over x. Remember that? And then we went to definition 2 and we said, okay, we're going to just hang out in quadrant 1. So we don't really need those x, y's, and r's. Let's just keep them in terms of opposite, adjacent, hypotenuse. So we said sine was opposite over hypotenuse, and cosine was adjacent over hypotenuse, and then tangent was opposite over adjacent. So working with that and the fact that we have this circle right here, this circle, we call it the unit circle because, bless you, its radius is 1. Every point on that circle is 1 unit away from the origin. Every point. How many points are on that circle? An infinite number, right? We can't count them. There's nice pretty ones, like this guy right here, he's 1, 0. And this guy's nice pretty up here because he's 0, 1. And this guy's nice and pretty over here, he's -1, 0. And this guy's nice and pretty down here, and he's 0, -1. Thank you. Okay, so if we think about those in terms of x, y's, and r's, and I look at these guys, what if my r's were 1? Well, if my r was 1, then sine would just be y over 1, or just y. And then cosine would be x over r, which is x over 1, so just x. Okay, what about tangent? Does he change at all? No, he doesn't have an r, so he's still y over x. Ugh. So what do you think cotangent is? X over y, perfect. What's secant? 1 over x. And what's cosecant? 1 over y. That means that any point on the unit circle, I can find all of the 6 trig functions for, using its ordered pair. Sine will be its y-coordinate. Cosine will be its x-coordinate. Tangent will be its y-coordinate divided by its x-coordinate. And then we can flip them to find their reciprocals. And you're going to say, okay, well, how do I use this unit circle thing, and how do I even make it? Awesome question. Let's make one now. I'm going to bring you one. And we're going to make it together. I'm giving you 2. You get to keep both. Don't hand them to somebody else. They're for you. One's for later. Ladies, I'll come back and give you another one. You're welcome. Okay. This is what's going to be your quiz come Wednesday.
Wait, this Wednesday?
This Wednesday. Okay, I'm going to show you how to make it. Okay? I'm also recording myself, so if you get stuck, go home and rewatch it in Canvas. Does that make sense? So, I'm going to show you how to make a unit circle. That unit circle is the same thing on page 140 that we were using. It's going to have degrees on it, it's going to have radians on it, and it's going to have every ordered pair on it. Those ordered pairs come from our exact value chart. Okay? Alright, so let's start with the easy things.
Will the quiz just be filling out?
Yes, here, I'll show you what it looks like. It's even sitting right here. There you go, there's your quiz for Wednesday. Do you want to see what's on it? It's right there. Oh dang, I showed you what's on your quiz. Okay. So I'm just going to give you a blank one of these and you just have to fill it out. Alright, so let's start with the easy things. First of all, we're going to label our degrees. I need to zoom out a little. It's not Okay, so here we go. Label the degrees. Let's start at 0. The first thing we're going to do is we're going to count by 30. Okay? The whole way around the circle. These guys are, this is the 30 degree, the 45 degree, the 60, the 90. We're going to skip the 45s and we're just going to count by 30. If you need your calculator, you can take 0 plus 30 and then plus 30. And you're just going to keep adding 30 the whole way around your circle. So here we go, 0. And we're labeling on the line. Like this is 30 degrees to that line. Okay? Skip the 45. This guy is 60 degrees. This guy straight up and down is 90 degrees. Add 30 degrees, 90 plus 30 is 120. Skip the 45. 120 plus 30 is 150. 150 plus 30. 180 plus 30. Skip the 45. 210 plus 30. 240 plus 30. Bless you. 270 plus 30. Skip the 45. Add 30. And finally, when we get back to here, what else is this guy? 360. You should have all but the 45s labeled around your circle. Well, now instead of counting by 30s, now we're going to count by 45s. Okay, so let's go back and fix those 45s. All right, so there's two ways to do it. You can count by 45s and add 45 the whole way around. Some of them are already labeled, but also know that if this guy is 45 degrees, how many more degrees is that than the one before him? 15, so you can take the one before him and add 15 if you want. Or you could take the one after it and subtract 15. Alright, so 45. If I count by 45, it would be 45, 90. 90 plus 45 is 135. Hey, looky there. That's the same as 120 plus 15. Add 45 would be 180. Add 45 would be... Hey, look. That's 15 degrees more than 210. 225 plus 45 is 270. 270 plus 45 is 315. Hey, look, that's 15 more than 300 degrees. You've now labeled the degrees the whole way around the circle. If you can do that, look at how many points you get. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17 out of 50. Not bad, right? Okay. Now let's go to radians. It's a little bit trickier, but if you can think about it in terms of fractions, it's not too bad. All right, now let's figure out what each piece of this chunk is. The whole way around the circle is how many radians? 2 pi, right? All right, let's label them so we don't forget them. What's halfway around the circle then? If the whole way around, pi. Okay, so there's pi. One full rotation is 2 pi, right? A half of a rotation then would be pi. Now let's just do some investigative work. If I break this apart into 30-degree chunks, 1, 2, 3, 4, 5, 6 chunks, right? Do you see that? 1, 2, 3, 4, 5, 6. That makes this 30 degrees, pi over 6. So now we're going to label our radians. First, we're going to count by pi over 6. Again, just like the degrees, we're going to skip the 45. So here we go. We are also going to get fractions, and when we do that, we must reduce them. Okay, so the first one here, 30 degrees, is pi over 6. 1 pi over 6. Now you're going to keep adding 1 to your numerator. 2 pi over 6, skip the 45. 2 pi over 6 is 60, but what does 2 pi over 6 reduce to? Pi over 3. If you need to write it down, that's okay. Jillian. Pardon? We broke this half of my piece, because this is 1, into 1, 2, 3, 4, 5, 6 equal pieces. So this is one of them. Okay, so here we go. 1 pi over 6, 2 pi over 6, 3 pi over 6. It's okay to write it as long as you continue to reduce it. So what does he become? Pi over 2, which makes sense because it's half of pi.
Wow.
Okay, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, which reduces to 2 pi over 3. Skip the 45. 5 pi over 6, does that reduce?
No.
6 pi over 6. Hey, we already did that one, right? Down here at 210. 7 pi over 6. He doesn't reduce. Skip the 45. 8 pi over 6. What's that reduce to? 4 pi over 3. Nice. All right, I'm down here at 270. 9 pi over 6, right? What does 9 pi over 6 reduce to? 3 pi over 2, which makes sense because I'm at 1.5 pi. All right, 9 pi over 6. 10 pi over 6. So 5 pi over 3. 11 pi over 6. That guy doesn't reduce. 12 pi over 6, I'm back to 2. All right, we're close. We almost have 17 more points. We have 4 more to label. So I guess we're at 13 more points. We're at 30 out of 50 right now. Okay. We count by pi over 6s for the 30 degrees. What are we going to count by for the 45s? pi over 4, right? If I take this guy, he's pi over 2. This would be half of it. Notice I've got 1, 2, 3, 4 chunks. So now I'm going to count by pi over 4. Some of them will already be labeled. All right, here we go. 1 pi over 4. 2 pi over 4 reduces to pi over 2. He's already labeled. 3 pi over 4 is 135. 4 pi over 4 is already labeled.
3 pi over 4 for the
135. Four pi over 4 is already labeled. He's 180. 5 pi over 4 is 225. 6 pi over 4, already labeled 3 pi over 2. 315 is now 7 pi over 4. 360 is 8 pi over 4. 8 divided by 4 is 2. He's already labeled. Okay? Are you okay so far? Questions on how far we've gotten? Now comes the fun. We've got ordered pairs to fill in. Are there some nice, easy ordered pairs to fill in? Yeah, like the guys that are on the quadrants. What about this guy over here? What's his ordered pair? 1, 0, right? Okay, how about this guy up here? 0, 1. This guy over here, mine's missing his name. -1, comma, 0. And down is 0, -1. Okay, now, think about what we talked about here just a second ago. If my R is 1, and my y coordinate is related to my sine value, and my cosine is related to my x value, and I know the exact value for everything in quadrant 1 in terms of sine and cosine, can I use my exact value chart to figure out these guys? Yeah, okay. So we decided that cosine was with the x value and sine was with the y value. So what is the exact value of the sine of 30 degrees? This is the part where it's going to take some memorization on your part. 1/2. What's the sine of 45 degrees? Root 2 over 2. And what's the sine of 60 degrees? Root 3 over 2. Look at what we just did. We took our exact value chart, that very first row in our exact value chart, and we had the sine of 0, the sine of 30, the sine of 45, the sine of 60, the sine of 90. Do you see that? What do you remember about sine and cosine? They're cofunctional. Perfect, right? So could I just rewrite this guy back down the same way? The cosine of 60 is equal to the sine of 30. So this guy's ordered pair is 1/2. Cosine of 45 is root 2 over 2. And the cosine of 30 is root 3 over 2. If you can get the first quadrant, I can guarantee you we can get the other 4 quadrants. 3 quadrants, yes. Man, math is hard. Counting. It's that counting thing. Okay, so what did we do? We found the exact values for each one of these guys. Now, remember, it makes a triangle, right? So if you're not sure, make yourself a 30, 60, 90 triangle. I want to show you one I have here. If I have a 30, 60, 90 triangle in here and my hypotenuse is 1, that means my short leg is a half and my long leg is root 3 over 2. It's kind of hard to see because it's colored in. Do you see that? But look at my ordered pair for that point right there. Root 3 over 2, comma, 1/2. This is like taking everything we've done and making it happen on one piece of paper. Okay, bless you. Same thing, I can make this purple triangle here if I'm not sure. My hypotenuse is still 1, so now my short leg is 1/2, and my long leg is root 3 over 2. Hey, 1/2, comma, root 3 over 2. Okay, so we've got some ordered pairs there in quadrant 1. We had a theorem back on the last section that said, or I guess it was 3:1. We had our reference angle theorem, and it says the trig function of an angle and its reference angle only differ by their sign, SIGN, positives or negatives. Remember that the reference angle for 30 here is the same as the reference angle for 330. In fact, this guy has so many lines of symmetry. I can do a line of symmetry this way across my y-axis, or I can do a line of symmetry across my x-axis. But what do you know about, let's just go down here to quadrant 4. What do you know about ordered pairs in quadrant 4? What's x? Positive or negative? X's are positive. Y's are negative. So these two ordered pairs are going to be the same. They're only going to differ by their positives and negatives. These two ordered pairs are going to be the same. They're only going to differ by their positives and negatives. These two ordered pairs are going to be the same. They're only going to differ by their positives and negatives. So this ordered pair right here is going to be root 3 over 2, comma, negative 1/2. Okay? 7 pi over 4 and pi over 4 have the same reference angle as pi over 4. So this guy's going to be positive root 2 over 2, negative root 2 over 2. Pi over 3 and 5 pi over 3 have the same reference angle, or 60 and 300 have the same reference angle. So this guy's going to be positive 1/2, negative root 3 over 2. Double check to make sure your x's are positive and your y's are negative. Okay, so like I said, that reference angle theorem helps us a ton. So we've got quadrant 1 and quadrant 4 complete. Let's go over here to do 2. What do you know about ordered pairs in quadrant 2? What about x? Is x positive or negative?
Negative.
All right, x is negative. What's y? Positive, okay. These two right here have the same reference angle. So 150 is going to have the same ordered pair as 30, except for my x-coordinate will be negative. So here we go, negative root 3 over 2, positive 1/2. 135 and 45 have the same reference angle of 45. So this guy will be negative root 2 over 2, positive root 2 over 2. 120 and 60 have the same reference angle of 60. So negative 1/2 positive root 3 over 2. Okay, last one to go. What do you know about the ordered pairs in quadrant 3? They're all negative, so you should have a negative x coordinate and a negative y coordinate. (210) has the same reference angle as 50 and as 330, excuse me. So you can either look here in quadrant 4 or you can look here in quadrant 2. They should be the same. The only thing that's going to differ is their negatives. So here we go. 210 is negative root 3 over 2, negative 1/2. (225) same reference angle as 135 and 315. Negative root 2 over 2, negative root 2 over 2. (240) same reference angle as 120 and 300. Negative 1/2, negative root 3 over 2. You just made a unit circle. Yay!
Yay. Give us a second unit circle.
No. I gave you a second one so that you can practice at home. Now, another thing, I have a whole pile of them. So if you need more, if you're like, I need more to practice, that's perfectly fine. Help yourself. I can go make more copies, okay? So I gave you one to practice between now and Wednesday, because that's what you're going to do on Wednesday. You're going to label all the ordered pairs, all the radians, and all of the degrees. Okay? Jillian, did you have a question, hon?
I was just wondering, in the third quadrant, why it was
So think about it as symmetrical with the x-axis. So these will be the same, these will be the same, those will be the same. So this ordered pair should have the same numbers as that ordered pair. They'll just both be negative. You could also do it this way. So these ones will be the same, these ones will be the same, these ones will be the same. Okay. Does that clear up about the unit circle? Okay, let's now use this unit circle. Okay, so number 1 there says, use the unit circle to find the 6 trig functions of 5 pi over 6. Okay, so look at your circle. Find 5 pi over 6. Where is 5 pi over 6? 150 degrees, right? All right, so now I'm going to look at my guy right here. Now, I will tell you sometimes it's like, okay, which one comes first? Is it sine or cosine? Remember, cosine comes before sine. It's alphabetical. So x comes before y. So this guy right here is my cosine of 5 pi over 6. So what's the sine of 5 pi over 6? 1/2. We've taken our exact value chart and put them across all 4 quadrants. So the cosine of 5 pi over 6 is negative root 3 over 2. Tangent, remember, is sine divided by cosine, or y over x. So this guy is 1/2. I didn't leave myself a whole lot of room here. Over root 3 over 2. Eek. Sorry.
Negative
The 2's cancel. I have a negative and a radical in the denominator, so he does become negative root 3 over 3. Sorry, that's really hard to see. So how about cotangent?
Where did you get all those values from?
My ordered pair. So cosine is the x-coordinate, sine is the y-coordinate. Good question. So this guy would be negative root 3 if I flip him over. Secant. Flip over cosine. So if I flip over, I've got negative 2 over root 3. So negative 2 root 3 over 3. Cosecant, flip over sine, so he's positive 2. Bless you. All right, number 2 says, use the unit circle to find all the values of theta between 0 and 2 pi. So this tells me it has to be in radians. If it said between 0 and 360, then it would be in degrees. But I want to look for my radian measures. When does cosine equal negative 1/2? Okay, well remember that cosine is my x-coordinate. So when is x equal to negative 1/2 on your circle? All right, so x-coordinate, I want x's to be negative 1/2. Hey, look, there's one. 120, right? But it said in radians, so 2 pi over 3. Does it happen again? When? 240, it told it wanted us in radians though? So 4 pi over 3. If it would have said 360 right here, then you could have given it to me in degrees. But it said between 0 and 2 pi, so that doesn't mean it has to be in radians. And I want to know when my x-coordinate is equal to negative 1/2. Does that make sense? Questions so far? Okay. Why is the sine function considered an odd function? This part just helps when we have negative angles. Okay? So an odd function says, if I take my function evaluated at a negative, that's the same as if I pull the negative out front and just evaluate my function. So sine is considered an odd function because if you're looking for a negative angle, find the positive angle, and change the sign. Oh, geez. Meaning, oh, sorry. For example, the sine of negative 30 is equal to negative times the sine of positive 30. So in an odd function, that negative matters. Cosine, on the other hand, is considered an even function. With an even function, the negative doesn't matter. So my function evaluated at a negative is the same as my function value evaluated at the positive. So no matter if the angle is negative or positive, the function value is the same. I should say the ratio is the same, the trig ratio. So the cosine of negative 30 degrees is equal to the cosine of positive 30 degrees. The negative doesn't matter with cosine. What does that do that for us? That just helps us use our circle with positive angle values. Okay, Jillian?
So, where do you get this from? Like, why? Let's still confused, like, why?
Why does that work? Okay, so let me look at your circle. Let me explain it to you with your circle. What do you notice? So sine we know is our x-coordinate, right? Or our y-coordinate. So if I look here, the sine of positive 30 degrees is 1/2. But the sine of negative 30 degrees is a negative 1/2. So it's an odd function because that negative matters. The only thing that's different between them is the negative out front. However, because cosine is based upon my x-coordinate, the cosine of positive 30 degrees is root 3 over 2. The cosine of negative 30 degrees is also root 3 over 2. So that negative doesn't matter with the cosine. Maybe. Let's try some and see if it helps.
It changed on quadrant 2 or 3.
So look at cosine, there's your x's. So they're both negative in quadrant 2 and 3. And then the y coordinates flip. So sine is still an odd function there because the signs are different. So these two will have the same x coordinate. These two will have opposite y coordinates. Yeah. Okay, so the sine of negative 60. What I want you to know there is that that negative matters. But I don't have negative 60 on my circle. So it'd be a whole lot easier if I could decide what to do with that negative without saying, okay, I'm in quadrant 4, that's reference angle. Does that make sense? So the sine of negative 60 is equal to the negative sine of positive 60 degrees. What's the sine of 60 degrees based upon your circle? Root 3 over 2. So this guy would be negative root 3 over 2. Okay, so the cosine of negative 2 pi over 3. I don't know about you, but I don't want to figure out where negative 2 pi over 3 is. But I know that a negative angle and cosine is equal to the same thing as the positive angle and cosine. So this guy is equal to the cosine of 2 pi over 3. So the negative can go away. 2 pi over 3, cosine of 2 pi over 3. Look at your circle, find the x-coordinate for 2 pi over 3. Negative 1/2. Ooh, now they changed it on us. Cosecant of negative 225. Whose reciprocal is cosecant? Does the negative matter with sine? Yeah, so he's going to come out. So he's negative times the cosecant of positive 225 degrees. 225. pudding. He's down here. Cosecant is, reciprocal is sine.
2 root, no, just root.
So let's flip him over. He's negative 2 over root 2, right? What's a negative negative? Positive. Rationalize. Reduce. 2 root 2 over 2. So that guy's just root 2. Okay, last one. It says evaluate the sine of 9 pi over 4. Is 9 pi over 4 in your circle? Dang it, what are we going to do?
Quit.
What do you don't quit? Thomas.
8 pi.
What?
Subtract 8 pi.
Subtract 8 pi over 4, right? Why did you pick 8 pi over 4?
That's 2 4 8.
That's 2 of them, right? He's going more than one way around my circle. Remember, if I subtract 2 pi, that would be a rotation. So if I take 9 pi over 4 minus 2 pi's, this guy would be actually 8 pi over 4 if I get a common denominator. So he's just pi over 4. So this guy is really the sine of pi over 4. And what's the sine of pi over 4? Root 2 over 2. So he's gone more than one way around the circle is what that guy's done. Okay, questions?
Do you need more than 1 too high?
Yeah, so he's gone like this. He started here, there's 2 pi, and then he went another pi over 4.
Thanks, dude.